Good afternoon, everyone. Getting another stream started just now. So this will be mostly a continuation of what we were working on last night. I got the file name actually from that experiment that was trying to brute force the bootloader on this bricked PLC device. So, as we kind of suspected, it was a pretty simple file name, but there wasn't really a good way to figure it out without doing a bunch of guessing, and automating that guessing seemed like the best way to go. So that experiment finished, and it told us the file name was up_bm.bin. So that definitely seems to indicate that we're probably in some kind of bootloader that's just looking for what I hope is a flat binary file on this SD card that it's going to load into either RAM or flash and run. That's what I'm hoping, at least. So this is still kind of a little bit of a plan B experiment. So this is trying to recover a PLC that was bricked during an earlier voltage glitching. So I've got a second PLC that I've been setting up to go back to running that same experiment. And then I've also been just trying to recover that original PLC using this SD card emulator that's been trying to brute force the file names. So I think I've been making some good progress on both of those. The actual voltage glitching setup, I think the next step there is to do some extra power supply filtering so that we can better see what's going on. Since most of it is connected, I still need to do a little more wiring on the FPGA side, but largely the problem there is just visibility on the signal is not so great because I didn't spend as much time doing power supply filtering on that board as I did on the original one. So, we could go back to working on getting that PLC rigged up, but I think right now the interesting thing to work on is to see if we can make some additional progress now that we know the file name on that bricked PLC. So that's what I'm going to be focusing on during this stream. Oh, Mark in chat says, Happy Thursday. Happy Thursday to you too. Thursday's a good day. It's, your day of the week impression I think largely depends on, what your day job is like and how much you like your friends and your coworkers. I mean, my coworker is usually Tuco, and I get along with him pretty well. So this is our contraption. It is currently powered off, but mostly set up for oscilloscope viewing. This is our Papilio Pro FPGA board running the actual glitching experiment, or not the glitching experiment, but the brute forcing experiment. It's emulating an SD card, and it's running software that's trying all the file names we care about, which is basically combinations of letters, numbers, and symbols 4 bytes at a time. We've established that it's using some kind of optimized aligned memcompare to do the comparison. So except for, it seems like the file extension, because it's only 3 bytes, is getting checked 1 byte at a time. So guessing the file extension once you know the rest of the file is actually really fast. But, the actual file name involves 2 32-bit comparisons. So you have to brute force each of those separately. So it took a few days to brute force the first half of the file name. Just because mostly of the order it was checking things in. I probably could have pruned back the character set to just letters, maybe numbers, and underscore, and it would have worked, but I didn't know what kind of crazy characters might be in there, so I just used a pretty wide set of ASCII. But yeah, this worked pretty well, and then the second 4 bytes actually came out really fast because it was mostly spaces, and that was near the beginning of the search space. Hello to more friendly faces in chat. Also, hello to people who are already on Friday. Friday is also a good day. All right. So I think mostly there's one random thing on here that's bugging me. I'm noticing a wire that just kind of came undone, but I think that is the relay output for the PLC, which I don't really care about yet. Anyway, I'm not going to fuss with that too much. I think the thing to do now is to get this set up so that we can go back to, well, just for a little bit of context, there were 2 pieces of software I was running on this emulator. So the emulator is called FlipsyFat. It's this other project of mine that you can find on GitHub. And it's a system on chip designed in Python with mysock and mygen. And for that system on chip, I've got a few different firmwares you can load into RAM. One of those is this kind of name brute forcing thing that we were running. That's called the word list firmware. And so that one basically works as having a main loop that uses just some for loops in this case to figure out what to guess. Try to get a little more of this on the screen. So yeah, this is, I mean, the version I actually ran was a little different than what I checked in because I was hacking on it still, but this is basically the same experiment. And so we would just generate these guesses, and then this function would end up, in the background, would try those guesses by fabricating file system root directories to send to the PLC, and then timing it as it was processing the root directory, and then when it gets to the end, resetting it so that it can try the experiment again. Oh, nice. For Teely in chat, Friday is in another 101 minutes, and for Amol, it's already Friday in India. Nice. Oh, cool. Vega in chat says that you inspire me so much to do more hardware-related stuff. I'll buy my first FPGA next month if it's in stock, a Mojo V3. That's cool. I'm not familiar with that, but I'm really glad to hear that you're thinking of trying FPGAs. I think they're really neat, and especially if you're looking for a way to get excited about getting more into low-level stuff and understanding like how CPUs work and kind of making your own hardware, I think FPGAs are a really nice way to do that, especially if you're already kind of interested in software. You'll have to kind of banish yourself of a few software-ish kind of habits because it's really tempting to think about writing hardware description language code as writing software, but it's really not, and so you have to kind of get over that hump. But once you do, I think you can have a lot of fun with it. So, and I've been especially recommending to people that they try out the, really, I think if you're new to FPGAs and you just want something that you can try out with not a lot of time or money commitment, I've been recommending people try to get one of the Lattice iSticks, which has, so that's actually the same board that I'm using in this experiment as a clock generator. This one right here. It is a Lattice iStick. You can get them for as low as $20, I think, if you get them from DigiKey or from another kind of first-tier distributor. And it's basically a relatively small FPGA right here. It usually has some configuration memory, but I disabled that on mine. And it has this FTDI interface, which you can use to program the FPGA and as a serial port. It's one of those dual UARTs that you can also use as SPI or JTAG or whatever. And it's a really nice board, and especially nice is that you can use the wonderful open source tool chain now. If you search for the Ice Storm tools, then you'll find this collection of open source tools, including a synthesis tool called Yosis that was written by Clifford Wolf, who also did a lot of the reverse engineering work on this FPGA. And then Arachne Place and Route, which actually takes the synthesized designs from Yosis and figures out where to put them on the FPGA. And so all that software is really nice, and it's actually a lot less annoying to use than the proprietary tool chains that most vendors have. So I think it's a good way to get started, and you can find some good tutorials online now. So yeah, I would recommend that. The Papilio Pro, which is the board that I've been using for this SD card emulator experiment, it's not yet supported by an open source toolchain. It uses a Xilinx Spartan 6 FPGA over here, but it's also been made pretty easy to start with if you're not really used to hardware development. They have kind of an Arduino style IDE that you can use to develop hardware for it. It basically links a ZPU CPU core. ZPU is a type of CPU core, and there's an Arduino port for it called ZPUino. And so there's an IDE that lets you basically compile ZPU plus whatever other hardware cores you want into something and send that to the FPGA. I think that's called Design Lab. So that's pretty neat. That's not what I'm using for this experiment, but if you want to use MySock, which is the system on chip I'm using for this, then it also has easy support for the Papilio Pro board. And this one's not as cheap as the iStick. It's like $80, but it's still pretty cheap as far as FPGA boards. I mean, if you want to get into like really high-powered FPGA boards, it's easy to spend over $1,000 for them. But for introductory level stuff, you really shouldn't need to spend over $100 for an FPGA board. So anyway, end of little FPGA rant. Oh, sorry. Cam was out of focus. I'm not sure which Cam. Sorry. Were we talking about the little one or the cat? Oh, okay, I guess it was just YouTube compression. Oh yeah, and yeah, Vega in chat says that they already did some software exploitation on the Nintendo 3DS and only recently began doing reverse engineering only for a year. Well, that's really cool. And also Coaster Melt was an inspiration. Well, that's really nice to hear. Oh, and don't worry about reporting stream problems, even if it doesn't turn out to be for everyone, because I'd rather know about it than not. So I appreciate finding out about these things. So, anyway, basically I think with this I want to go back from using this word list experiment, which was really just designed to be optimized to just go through these guesses as fast as possible, or at least as fast as I felt like implementing. You know, it's always trade-offs between how fast you can make the experiment go and how much time you spend optimizing the experiment, but I did at least make this fast enough that it's not so good for interactive experimentation anymore. So I actually want to go back to this other program, dentry-frob, which stands for directory entry frobber. If you don't know, frob is kind of an old hacker slang for just kind of like mindlessly poking at something until it works. And so this is basically a little program that lets you create a bunch of copies of the same file on the SD card and then hex edit their directory entry in real time so that you can see how the firmware responds. So right now we're getting to this point where if we give it a normal file entry, you know, that isn't a volume label, and we give it the file, you know, what was that? I keep forgetting the file name because it's so obtuse. upbm.bin. So if we give it that file name, then we know that that's the right file name because it stops scanning the directory, but it doesn't actually get to the point of reading the file yet. So there's something wrong with the directory entry header. So there could be a bunch of reasons for that. You know, one reason that I've seen in the past is the cluster number points to something that is not actually marked as allocated in the FAT, but I think we've actually marked pretty much everything as allocated, so I don't think that's going to be it. Currently, the top candidate is that the size is either not exactly right or just not large enough. So the gist of this is I want to start poking around with these values and, like the name on the tool says, kind of frobbing the directory entry until it does something interesting. And oh, I just noticed a question from David in the chat about Coaster Melt. So David says, apropos Coaster Melt, did you lose interest? I really like that project. Well, I guess a bunch of things happened with Coaster Melt. So, I mean, for people who don't know, that was a project I did where I did basically the output of that video so far is a couple of videos that are like, if you've only seen these streams, I also, much less frequently because they take so much work to do, but I really like doing these kind of highly edited videos that are usually much shorter. They kind of range from like 5 to 30 minutes, and they tend to pack a lot of content into a small amount of space. So one of the earlier of those videos I did was on, well, a couple of them actually. I did 2 of these. They were on this project called Coaster Melt, where I reverse engineered enough of the kind of firmware and undocumented bits of the USB protocol on a Blu-ray rewritable drive in order to get code execution and basically an interactive debugger environment running inside the system on chip on the Blu-ray rewritable drive. And so the ultimate goal of that was to make something where you would have kind of direct control over the interesting hardware on there. So like the laser, the kind of servo that aims at the you know, all the other kind of more mundane motors that just spin the disk and move things around. Like I wanted to get control over that. And then there were a few different tools I could imagine making. Like, you know, you can imagine, well, what if you could use that as like a really high-res scanner? So as it's going over the disk, could you also, you know, use that really high bandwidth input channel and log the little deviations across the surface of the disk and use that to kind of create an image of something that you've placed on top of the disk? The thing that I was most excited about when I made the video was creating basically a system for laser graffiti using really cheap components. So use an off-the-shelf rewritable drive to burn effectively a holographic diffraction pattern into a disk, you know, using the hacked firmware to be able to burn something onto it that isn't just regular data, but would probably be using the optical, you know, would probably be using the bandwidth actually available in the system to create kind of a higher resolution image rather than just limiting it to something that is actually recoverable as bits by another drive, if you get what I'm saying. So, I don't know, there were a lot of components in that project, and I guess part of what I liked about that was that it did have so many moving parts and so many areas where it seemed like I could bring things together and maybe offer people things that would be interesting. So what I ended up doing was creating a little software toolkit that you could get, like an interactive Python shell that let you kind of fuss around with the memory and processor state in there, and these videos. And I was almost at the point of getting to reverse engineer enough of the on-chip hardware that I could start programming it to do kind of interesting things. So, I identified some of the registers that controlled like the motors, and I could demo running some Python code that would get the motors to hop around a little bit, but I didn't really understand them well enough to do anything interesting. So as for why I stopped, part of it was I intentionally wanted a little bit of a gap between that first part and the next part, because that seemed like a really interesting place for other people to jump in and start experimenting with the stuff that I'd released. So I wanted to give it a little bit of time. I didn't want to like lick all the cookies. I wanted to, be able to give people an opportunity to explore on their own using these tools. But then I also ended up just having a bunch of personal upheavals in my life that made it kind of hard to produce content for a while right after I did that. And so, it was mostly just that a lot of personal stuff happened, and when I finally did start to put myself back together, I just ended up having different stuff at the top of my priority list. So it's still something I'd like to do. It's just, that's kind of the way the projects shake out. And so I think at this point my feeling is partly, well, I could work on it more, but I could also like let some of you work on it, and I think that would be cool too. But I think it would be fun. I would certainly enjoy picking up the project again. I've just always got so much stuff on my plate that it's kind of a prioritization exercise. Oh, that's interesting. I'm not sure how to pronounce your nick, but INXL, I guess, asks, is there an open source USB debugger? I don't know of any. I think that depends on what you mean by debugger. Yeah, if you're talking about like something that like debugs chips, then there are various things. Like check out the things OpenOCD supports. Also, yeah, the Blackmagic probe I hear is awesome. Oh, and Mark says, while we're doing Q&A, can you talk about your scanlime logo? I guess. What do you want to know about it? I mean, I think it pretty much is what it says on the tin. There isn't really that much behind it. Oh, and see, Aleph in chat says hi to Brenda. Yes, my friend Brenda is still here. She might be quiet, but she is welcome to talk. I haven't told her not to say things. Oh, and for debugging, okay, so INXL clarifies, for debugging the USB protocol in software or hardware USB debuggers are expensive, especially for USB 3. Yeah, definitely. I agree with that sentiment. I think the most, well, so I was trying to, like, if you know about the, well, I guess there have been a few projects over the years. Like, I was kind of a little bit involved in OpenVisla while that was happening, but there were some projects for doing like open source USB analyzer devices, but I'm not like really at like an expert to talk about the state of those right now. Like OpenVisla kind of took a while to come to fruition, and I don't think there are any plans to support USB 3 there. And I thought I saw another open source USB analyzer project fly by, but that did support USB 3, but I don't know, and I don't know that that would be inexpensive either. But so yeah, for hardware, I mean, that's probably going to be expensive. I've got one of the Total Phase Beagle analyzers, the 480 megabit version, which is not cheap, but also not nearly as expensive as the Elysis gear. So yeah, I find it really useful to have a hardware USB analyzer for the kinds of low-level stuff I usually end up doing, but it is an expensive thing to have. So the other thing I often use is, so I used to work at VMware. Some of you might know that, but I worked there for like 6 years, and the two things that I mostly worked on were the virtual GPU, so like 3D, 3D rendering, shaders in a VM, that kind of stuff, and USB emulation. So, and I guess I also wrote the Bluetooth stack there. But like for USB, I was mostly involved in like USB 2 and USB 3 support. But then also ended up doing things like, how do we make USB work on Mac OS? And I wrote the VMIO plug kernel module and stuff like that. And so one of the things that I ended up doing there, because I needed to debug USB a lot, and we had access to hardware analyzers. Like, they weren't just like, they weren't buying us necessarily all the tools we needed, but they at least had a couple of Elysis analyzers for the team to share, which was nice. And man, I still had to bring in so much of my own electronics gear from home, which now that I think back to how much money they had was pretty ridiculous. Like, I really should have just gotten them to buy me the tools I needed. But yeah, I ended up actually getting a lot of mileage out of just adding some debug logging to the USB emulation core, and then having this other tool that processed the log files. And so actually, there's a similar thing available in. So this was VMware, which you can use any of the free versions of VMware to do this. There's also a similar facility built into Linux now called USBmon. But basically, the thing that I built was this, which I think you can still use, but it might actually be better these days to use Wireshark, since I think Wireshark supports USB analyzer kind of stuff nowadays. And so you can use either a virtual machine. So I think this page kind of tells you how to enable the logs in VMware. Yeah, this tutorial. Yeah, so I think this should still work. Like, this was written ages and ages ago, but I think it's all still valid. If you go here, vusbanalyzer.sf.net/tutorial, then this will tell you how to use any of the VMware products to act as a software USB analyzer. And that's really nice because the software inside the VM doesn't have to know anything about it. Like, it doesn't know that it's being captured. It'll just act normal. So this works for debugging kernel drivers, for example. The other thing you can do, there are some tools on Windows that act like USBmon that will capture at like the driver URB level. I'm spacing out on the name of those tools off the top of my head, but you can probably Google for them pretty easily. But yeah, basically, if you look at the analyzer tools, like both this one that I wrote, this old USB analyzer, and Wireshark, I think they can open a couple of different log formats. So like USBmon can do logs, and VMware log stuff in the same like text-based log that your VM spits out. Oh, this also supports diffing USB traces. So this might be useful. I also like the little graph view that I ended up doing for this, and I've been kind of wishing that more people implemented that, because I find this really useful for debugging. I designed this for debugging isochronous traffic. So when you have a device like a webcam, you find that there are all these timing relationships between so normally, in normal hardware, you have these packets that are scheduled to go out on a fixed schedule. So like, say, every 4 milliseconds, or every millisecond, or 4 times a millisecond, you'll be delivering a packet of a fixed maximum size. And that's how your webcam gets a reserved amount of bandwidth on the USB bus. So if you ever plug in a device and you get some error message from your OS that says we don't have enough bandwidth for this device, it might not work right, that's because it's a device using isochronous that asks for a guaranteed time slot to send this many bytes every this amount of time. So when you're doing that, there are just a lot of other layers that interact with that. So under under that in the driver layer, the driver then has to submit basically I/O packets to the host controller driver frequent enough to keep the host controller driver's schedule filled. And then when we're emulating all of this in a VM, the layer that actually emulates the host controller has to go back through and scan that schedule that the guest's driver filled that normally the hardware would be reading. And we have to kind of cheat and like look ahead in that schedule and try to snag the transactions as soon as they're actually put there, and then create an equivalent transaction to put in the host's schedule. So that basically, as the guest is putting stuff into its schedule, like in the future, where the hardware shouldn't be looking at, we're kind of like peeking ahead of there and like, filling it into the host. So it's kind of crazy, and I needed a way to debug that. So. Oh yeah, INXL says, hopefully SourceForge won't close. I think I might have, did I copy this into GitHub? I think at some point I started importing some of my old projects into GitHub, but I wonder if anybody did this. Oh yeah, I did. Okay, so I guess the website is still mostly on SourceForge, but the code is on VUSB Analyzer. GitHub edition. So yeah, I did think of that, because SourceForge has been steadily declining over the years, for sure. Oh, GRG in chat says, yeah, Wireshark offers USB PCAP now. Oh, okay, so I guess if you install Wireshark on Windows, then they'll let you install a driver for capturing USB as a PCAP file, which sounds helpful. That's nice. And I also know of some standalone tools for Windows, which, like I said, I'm forgetting the name, but how a really dumb name too. I'm forgetting it. But there's some tool that basically it installs a kernel filter driver between the USB host controller and the other USB drivers, and then has a user mode application that attaches to that driver and slurps off all the traffic and stores it. So, oh, there's some context questions in chat. So yeah, just for a bit of context. So yeah, overall, this is about reverse engineering a PLC. The kind of big picture problem here is getting the firmware off of a PLC device that has some communication over Ethernet. I'm trying to glitch the Ethernet communication while it's trying to figure out what to respond with in order to get it to respond with its own firmware. I have a proof of concept doing this on another device that has known firmware and giving us like a small section of the firmware, at least 64K of it. So then I tried to port that to the real device, and then I accidentally bricked it. So now I'm in parallel basically getting another device prepped to do the same experiment and pick up where I left off, and I'm trying to unbrick the first device, or at least use it to do some different experiments in this bricked mode. Oh yes, that's it. Dr. Toon says USB Snoopy is the name I was looking for. Yeah, silly named Windows sniffers. There's a few of them. But yeah, USB Snoopy is the one I was thinking about. And yeah, it's pretty old school. It might not really work on modern versions of Windows even, but yeah, if you search for USB Snoopy, you'll probably either find that or something else that works. But yeah, it seems like maybe Wireshark has something built in that's worth trying too. So yeah, overall, this is about glitching the PLC to get the firmware out. But then specifically, I've got this experiment that I was running this over the last few days, and yesterday it actually came up with the file name that this bricked PLC has been trying to load off of the SD card. So I don't really know much about what it's doing, but it's been pulling the root directory off of this SD card. And so by brute forcing the file name 4 characters at a time, I have the file name, and now we're just trying to get to the point where, well, basically I'm trying to set up an experiment where I can kind of wiggle through whatever it's looking at next to try to figure out how to give it what it wants such that I can get into the system. And if I'm really lucky, I can do this without it erasing the flash. Since if this is a bootloader looking for an image to program onto the system, there's a really good chance it's going to be erasing the flash as soon as it validates this image. So one thing I'm concerned about is designing this experiment such that I don't just let the firmware continue running in the state where it's erasing the data that I'm trying to get off of it. So I think the way I'm going to set up the experiment is to hook the reset line back up to my signal generator so I can just have it periodically reset. And then actually, as the experiment gets further along, I can just step out the period of that reset generator so that I'm very deliberately letting it get a little further along before kind of killing it and resetting the experiment. And so the previous version of this that I had going last night, I was manually rebooting it, but now I'm going to be doing that automatically and letting that drive the process of it pulling file names off of the kind of hex editing SD card emulator. Yeah, Dr. Toon says, this sounds difficult. Well, I'm going to guess that it has a header and CRC in the firmware image, and it would be hard to fuzz. Yeah, probably. I mean, like the thing is, if it all kind of boils down to how easy it is to tell where it's making the comparisons that we care about. Because if we can figure out what it's, what is that next comparison, then it's probably not going to be more than like 16 or maybe 32 bits of actual information that we have to brute force at once. I mean, I think the worst thing is if it's just doing a 32-bit CRC and we have no idea what the CRC is, and we just have to brute force that, in which case it would take a while. And in that case, we might look for a faster way to run the experiment. So yeah, I mean, there are a lot of ways that this could turn out to be really hard and not practical, but it seems worth digging a little bit further at this point. And if we run into a really tough wall here, then maybe I design a brute forcing experiment that'll take a while and let it run in the background while I continue working on something that makes a little bit more sense to spend time on in the immediate future. So I think that's how this is going to do. Oh yeah, a couple people in chat were asking about the file name, and yeah, just to clarify, it is just upbm.bin. This hex edit up here is just the way directory entries look in FAT16, and it's just 8 bytes of file name and then 8 bytes of file name and 3 bytes of extension. No dot, the dot is implied, and everything is padded with spaces instead of nulls. Yeah, so I think right now I'm just going to get this hardware set up so they can do that resetting to hopefully keep this not just running off into reset clear flash land. That little song was courtesy of my hot water machine. Okay, so I'm just going to take this off of here, and I had a little BNC breakout somewhere around here for just this occasion. Maybe I need one. Carefully eyeing this thing to make sure it's not going to mess up my... Actually, I think I should just give this an extension lead. Extend lead. Oh, this is the one I was actually looking for. So, something like that. We have some good cat going on. Look at that cat. Man. Milan in chat is saying, I'm guessing that the UpBM stands for Siemens Update. Is BM related to Siemens somehow? I always assumed it was some kind of abbreviation for bootloader or, boot image or boot manager or something. Oh, nice. Sodium helpfully posted a link to the VUSB analyzer in chat. Thank you. Okay, so how much time should we give this? Let's start with not very much, maybe. Wave gen. .3 volt logic. Okay, now I'm just going to trigger the scope on the reset pulses for now. We will probably want to trigger it on something less noisy, but this will do. Let's reset it. Well, yeah, once a second is probably a good start. Okay, I guess the first step actually is setting the clock generator and all that stuff back up. Powering up the chip whisperer. Oh yeah, someone on chat, I forget who, because I just barely remembered that I forgot to answer this question, but sorry about that. Someone was asking about inexpensive resources for side channel analysis. And I think that's pretty much exactly what the Chip Whisperer Lite was designed for. So, I mean, it certainly isn't going to be perfect for everything, but that's basically what Colin O'Flynn had in mind was, how do I design something that's inexpensive that'll help more people get interested in or get involved in side channel analysis. So, oh, Mr. Anbox in chat was saying, interesting, and we know it leaves a file called logoup.bin on SD cards too. Well, the logoup.bin is really different. Like, I think this upbm thing is, and then Emily is saying we got to upbm space.bin, or did it turn, so to clarify, the way files work in FAT16, the file names are padded with spaces, so like, having a file name that's truncated and having a file name that ends with spaces are identical. So this is just how it represents this particular 5-letter file name in FAT16. So like this is not, it would not make sense to have the extension be earlier in here. Like this is not one string, this is 2 strings. This is an 8-character string followed by a 3-character string. So that's just the way DOS file names work. They aren't a single thing. They're a file name and an extension that are separate. And then the other file, that logo up.bin, that was also, I think, pretty different. Like I don't think that was, like that was just, I think, like, so I haven't compared this exactly, but my current working assumption is that it's basically just the contents of this SPI flash with a header on it, and the SPI flash here has the contents of the PLC program. So it's not the firmware, it's basically the interpreted program that's running on the firmware. So it's not very useful. Like if we can find bugs in the firmware that we can exploit through that, it is, but like extracting that isn't useful because it isn't hidden at all. Like that file is already completely within our control. And we could try doing things with its inputs, but that's just like a separate experiment. That just doesn't have anything to do with the line of inquiry that we're going down right now. So, okay. Anyway, let's get this experiment set up. I think I just need my other VM back. Chip Whisperer. Man, such a good cat. So this is set up normally. Now we need the FPGA. Man, so the last time I had this bug where it seemed like, well, so I was trying to get the, so much yak shaving. If you haven't heard the term yak shaving, I feel like it perfectly describes the kind of work I spend most of my time doing. It's basically the kind of thing where, you know, you're trying to do one thing and then it just, you end up like stacking so many little subtasks on top of that, so you're just like so far away from the thing you were originally trying to do. And I don't even remember exactly the story about why it got called yak shaving. I think it was a joke from a cartoon that I never saw. But yeah, so I was trying to get that PLC program loaded onto here. So not the one that we're trying to get to through the SD card, but the one that I'm trying to voltage glitch over here. So I was trying to just load the experimental program on there, the one that I'm using to toggle outputs to give me a time reference. And to do that, I needed to get the Siemens PC software, their soft comfort tool, to talk to this thing. So first I just had to fuss with Ethernet bridges a bunch to get them to talk, and then it turned out it was timing out because it was underclocked and this thing was taking too long to respond. Then I had to speed it up again, and I started hitting this problem which seemed to be just related to it running faster, but then it turns out it was because, well, to make it run faster, I was using a different FPGA image, and that FPGA image ended up not defining some of the IOs. One of those IOs was connected to the reset puller transistor, and the pull-up resistor that is the default on unused IOs on an FPGA was enough current to actually activate that transistor and yank the reset low, causing the PLC just not to boot. So, yak shaving, debugging, stuff like that. Nicholas in chat says, AKA cat herding. Yeah. Len says, I don't think of yaks, I just think of you somehow ending up in a place where you just have to build a neutron generator for some reason you can't quite remember. That sounds about right, too. Wesley says, I like counting how many sub-problems I am away from my actual goal in yaks. I'm now 4 yaks deep. I feel like I would just be really bad at keeping that straight, and if I did remember, it would just be depressing, but I applaud your efforts and results in that domain. All right, I think I just want this other console. Oh. Oh, is that not the problem? Do I accidentally have that connected to the VM? Either of the VMs? This one just has the chip whisperer. This one doesn't have anything, which is that right? Yeah. Let's try replugging this contraption. Am I having USB problems today? This is plugged into the right computer. I don't see it in this list, actually. So this one's the chip whisperer, clearly. This one, this lattice FT USB thing. Oh, I guess that's it. That's the iStick. That's right. I was expecting that FTDI to be the Papilio, but that's not plugged in right now. Maybe I'll just connect this and disconnect it to see if that helps the host see it again. Ask me someday over a beer about how this works. Maybe I can... It's actually difficult to unplug just this one board from the hub that it's on. Erg. Huh. Do we have a different FTDI thing? Is this computer just cursed now? I mean, that's definitely on the host. I'm not used to USB or IO Registry Explorer still. I still kind of like USB Prober. And what I'm looking for now is an indication of whether or not there's a driver connected to this such that the user space code here can't use libUSB to access it. I don't think this is telling me which drivers are binding to it, which is kind of annoying. Because these devices up here are clearly going to be used by the HID driver because they're input devices, but we're not seeing that. Would that show up in IO service plane, maybe? Oh yeah, so okay. So basically these are different ways of looking at the device tree that macOS uses internally. IO USB just shows you the USB related parts of it, but IO service is like the base class for all of this, so this shows you the whole thing. So you can kind of use this to filter this tree down to just the USB stuff. And then, like, this is the device we care about. And then we go back to IO service, and we should be able to see what else is attached to it. Google Chrome? What the shit? Why is Google Chrome connecting to my USB devices? Did you enable something stupid by default, Google? Oh wait, how do you get there? I accept that it might be theoretically possible to have a secure and well-implemented USB in the browser. Theoretically. It's extremely hard, and it's not a good sign to see that they're already binding to all the devices on my system, even though I'm not doing anything here. Yeah, okay. I'm curious about this. This is not making me happy, but it's not related to what we're doing right now. Anyway, I don't see any other processes using it. Well, this is weird. I'm going to try killing Chrome just in case, but I don't think that would be the problem. I might be running low enough on ideas that killing Chrome, trying it again, then killing VMware, trying it again, then rebooting might be my series of operations. Let me replug this just to make sure. Still not this. Yeah, I mean, so if you're wondering why I'm so annoyed about the USB device thing, it's that there's this fundamental relationship of trust between both the devices and your operating system's drivers for each other. So, and you can try to fight against that, but it's really hard. It's just like always been how drivers work, that they can trust the hardware and the hardware can trust your drivers. And so now if you have web browsers talking to your devices, the device doesn't have any way of authenticating which process on the computer is speaking to it. So that's always what we've relied on kernel drivers to do is, they're the arbiters of what's okay to send to the hardware because the hardware isn't smart enough to filter things for itself. And so it's really convenient if you can just have a pipeline that completely bypasses that layer for every kind of I/O, but it's impossible to secure without completely re-implementing the way USB works. So geez. And yeah, like, there's supposed to be like a whitelist from what I've seen. Like, I've complained about this on Twitter before, but I don't know. It's very concerning to see that they've already got a user client binding to all the devices on the system, and I haven't even got a website running that uses it. So it makes me want to read their source code and see what's going on there. But that might be a thing for another stream. Oh yeah, and so Garrett in chat says that has a bit about U2F, universal two-factor extension only requesting the Ubico vendor, but I don't think this is U2F. I think this is actually like a USB, I forget what it's called, but it's like a way of accessing USB devices in JavaScript, which sounds very convenient and like a terrible idea. Like I mean, I don't know. I can see how you might think this is a good idea if you aren't a curmudgeon like me who spent 6 years trying to deal with broken USB devices that are doing stupid things in virtual machines. But like, it's exactly the same security problem that you have with virtual machines. And like in VMware, like we took a lot of pains to try to make it as secure as we could, but we still tried to warn people that there's really no way to prevent somebody from like flashing the firmware in your keyboard if it has access. So somebody's going to make a really interesting POC, and then everyone's going to actually see what's going on. Oh, Garrett in chat wrote this in Chrome. Well, maybe you can tell us why it's attaching to all the devices then. Yeah, because I'm pretty curious about that myself. Okay, I'm going to just reboot this computer because I think something is really messed up with its USB stack, preventing me from using the FTDI device. And while I let this reboot, I'm just going to attach this cable that I still need to attach. Microhacks in chat says that I need a heated decoy laptop for Tuco. Yeah, pretty much. We've thought about making, like, just taking an old keyboard that he likes or something and putting a heater in it. I mean, I guess I could also put the laptop that I usually run the audio on down there, because I don't usually need to, like, I could leave the keyboard locked, but he'd probably still find a way to kernel panic it. I need more room on this breadboard. Oh, and this booted already. Great. Oh, okay, so Garrett's clarifying that there is a VID, a vendor ID, product ID whitelist that the extension requests, so it shouldn't be binding to all of them. So that's interesting. I wonder what's going on there. All right, that's not the window I wanted. Let's just see if I can, I still want to do, I probably need to kext unload again. I don't think I permanently disabled FTDI on this machine. Yeah. History grep, kext unload. Okay, well I unloaded it that time at least. Okay, that worked. I guess the kernel USB stack was just in a really unhappy state somehow. And let's see if maybe that was just a kernel bug that was causing the USB clients on Chrome to not detach. Although, like, I don't know why they would be attaching in the first place, but like, I'm curious now to take a look at this in IO Registry Explorer while I start Chrome. I don't want to spend a bunch of time on that on this stream, but I'm very curious. Okay, so here's a bunch of devices we might care about. I think this is one that I saw it attaching to last time. This is just like the built-in receiver on the Mac Mini. So if we switch to IO service plane, we can see the drivers under there. Apple USB interface. Well, we'll see a few of these. So then I open Chrome. Oh yeah, and now they attach. All of those attached as soon as I opened Chrome. It's attaching to the hubs, to the receivers, everything. What kind of a thing is this? This is an IO user client, so it's opening these in user space. It has a handle in user space for these devices, which means that anybody in its address space could start sending stuff to these devices, and it would no longer be different from normal behavior. That's fun. Fun is one word for this, which I will use right now. There are other words I could use for it. Anyway, I think we've got a clock. Oh, wait, no, we've got the FPGA loaded, but I still need that VM for the clock generator. Yeah, this is the right VM. Dr. Toon in chat says, it seems really crazy though. It's like Google had a meeting and thought, okay, what haven't we hooked up to JS yet? Next, the laptop LiPo charge controller. Because maybe you want to write a custom charge curve, and like you can't learn C to write that kind of stuff. You have to make that kind of coding accessible to anyone that knows JavaScript, right? You wouldn't want like memory safety for your battery charge controller or like your motor drivers or anything like that. I guess that's one thing that kind of bothers me about like a lot of the kind of mass approaches to programming right now, is that there isn't necessarily a, like people aren't really taught why you would want to use a tool that makes things harder. Like what is the actual trade-off there? Like why would you want to use something that involves no dynamic memory allocation? Well, the trade-off is, well, now you can never have a malloc fail. You can never have a use after free. Like there's a whole class of bugs that you just completely eliminate. And then, you know, at a more meta level, it means that, well, now you're thinking concretely ahead of time about all the resources your program might need. So there's never going to be any mismatch between how much memory, you know, your program actually needs and what's available. So I don't know, it's both more of a rigorous approach than I see most people using in practice, and more practical than I ever was taught in school. So I don't really know where people are supposed to learn that stuff other than by failing a whole bunch. Dr. Toon says, set max LiPo cell voltage could be just a JavaScript function. Yeah, GPU overclocking in browser, says Greg. Yeah, these are all things that I fear our current dystopia might be bringing us. Anyway, speaking of things that are weird, let's see if, I guess I need to restart this because this cannot maintain the state of the device as it's unplugged. I guess I need to attach this to the VM too. Yep. Every time you hit that menu to reattach the device, the VM is sending an I/O control to this driver called VMIOplug, which basically goes into the device at a pretty low level and simulates it unplugging and plugging back in. And then it has a state machine such that when it plugs back in, it remembers to attach it to the VM instead of your host machine. And I don't know. I'm trying to limit the depth of the yak stack, I guess, but just imagine some of the edge cases that might have, and then maybe take me out to a beer and we can talk about it. So I think we just need to restart the PLL, and then we'll actually have a clock. Yay, we have a PLL lock. Our clock is blinking happily. Okay, so that's pretty nice. Anyway, I think I'm going to try to focus on this particular experiment, though, which doesn't need that clock generator. That just helps me feel better about my overall setup here. So let's get this reset line attached over here. I'm not used to having two experiments on the desk, admittedly. I keep being like, oh, I could do a little work over here. I could do a little work over here, which is actually how I usually do things in the lab. But it's probably not optimal for either the streaming experience or my later sanity during video editing. That goes there. Does need some groundage. Now let's plug this into a ground that's actually kind of nearby, because that's nice. Maybe a ground that's nearby and isn't covered in epoxy would be helpful. I think we discovered a new mode for the stream, that you get me on an off-topic technical rant, and then I just start doing work on unrelated projects without noticing. I mean, I guess it's not an unrelated project. It is like just the other half of this, but still. Okay, so the scope is still sending out a reset signal once a second, and I'm going to power the rest of this off this USB, and I want this to be passed through directly to this VM. Oh, Kyle says hello from Germany at the Troopers Conference. Nice. Oh, John is speculating about the Chrome weirdness that I'm seeing in IO Register Explorer. If it could be that the USB device discovery is being overly aggressive or buggy. They're suggesting if it requires having a handle on hubs for notification, it might be recursing too deep. Well, so that's how notification works in Windows, but it's not how it works in macOS. Like in macOS, you don't need to open a user client to get notified when a device comes or goes. You can get, I'm forgetting what it's called, but it's basically you register to get notified. Yeah, I'm forgetting what the name of the structure is, but there's like an IOKit primitive that you can use to get notified when something in the IO registry changes. So like, that same primitive was being used by IO Registry Explorer. So like this program itself is getting the same notifications that Chrome would need, and it's not populating this with its own clients. So like, clearly there's a difference here. It doesn't need to do that. It's either something that is buggy or just kind of a bad idea. C4757 has a wonderful suggestion. They say I use a 20-foot pole minimum for touching any software. Yeah, that's probably a good distance. We should do a study to see what pole lengths are most effective. All right. I want to make sure I can see this once it starts up. So when I plug this in, now the PLC has power, but it's not actually going to have clock until I start up the FPGA. Do I not have keyboard in this VM? How do I not have keyboard? Do I have keyboard outside this VM? Oops. Yes. Let's just restart this VM. I think this VM needs to be recycled. JKFX also says hi from Germany. Awesome. Hello. C4757 develops KiCad code, apparently, says Kyle, so he probably can't get a long enough poll. Yeah, I mean, it's tough to be, I feel like anybody who works with software long enough ends up like with this deep-seated distaste for it, but then you usually end up having to be around it anyway, so you're just kind of turned into a trash monster. And then they say, I have to admit the long pole makes it hard to edit the code sometimes. I should probably just get a bigger keyboard. Yeah. And Jan adds in chat, Chrome has your keyboard. Yeah, see, that's the thing. Like, if Chrome has all the USB devices, then, like, it's going to have trouble opening the interfaces that are going to, like, I don't know if it'll actually work out to implement a keylogger that way, because the kernel is still going to have precedence over your user space device per interface. But it could still let you have shenanigans, like, what's to prevent the browser from using an interface it does have, namely EP0 control, to send something to the keyboard that causes it to reboot. It could even just send it a USB reset, because that's probably allowed. And then the keyboard reboots, and then you just race and try to claim it before the kernel HID driver does, and then you own it. It's just, I can think of so many ways for this to break, because like the hardware doesn't protect against this at all. Like the hardware completely trusts the operating system. That's just how it's designed. INXL says, also USB sucks above 20 feet. Yeah, I've had trouble with USB extensions plenty of times. It's usually one of those things where it's like, oh man, this works. It's so great. And then you leave it and forget about it for a while. And then you're like, oh man, why is my USB having all these weird problems? And then Garrett adds, USB at sea level only. Yeah, definitely. Definitely had trouble with USB on flights, probably for that reason. So we want the dual RS-232, which is the Papilio Pro. I just happen to know from memory, not like anybody could tell just from looking. And what do we got? Source, flipsyfat. So just for reference, what do we have in this tree that is not in GitHub? We have some changes to this and to the other word list experiment. So here, mostly the changes are just to support the clock out and the reset out. It might be worth checking those in. What about, I should make sure that this leaves the reset pin high impedance when it's not using it, so it doesn't fight with my oscilloscope. Yeah, so this is using GPIO OE right. That's right. So this is not using a transistor to pull down the reset. This is just using GPIO in kind of open drain mode, so that it pulls it down to ground and then lets it go and lets it float. Just catching up a little bit on chat. Actually, let me put the screen up here so that you can read along while I'm doing that, if that's a thing you're into. Yeah, a lot of love and hate for USB in here, I'm sure. All right, bootloading time. All right, so now this thing should be responding once again. We've still got our default file name that isn't going to do any harm. But now I want to zoom in on the scope and try to see how big this reset window should be for safety's sake. I'm not seeing this give me anything interesting either. What am I missing? This is definitely missing something. I mean, the scope should be issuing resets. Oh no, the scope is holding it in reset. I need to adjust the polarity on here. Let me unplug this while I'm adjusting the scope. Yeah, if I unplug the reset line, then the screen goes back to the darker gray, indicating that it's actually running, and you can see it reading the emulated SD card now. A little confusing having both of these experiments right next door now. Okay. I want this to be an inverse pulse. Let me just swap these. No. Oh geez, not 10 volts. This is why I disconnect it when I'm adjusting it. Back to logic presets for CMOS here. I want a pulse that is normally high. Am I going to have to do this with a transistor, or can the scope do it for me? Oh, here we go. Invert output. Great. Great. Okay. Let's plug that back in, and then we should get our every second resets. I think that's what we want. Why are we not triggering? Oh, this is really zoomed out. I see. I think this is not enough time for it to finish booting. Let's let it get a full trace at that scale. Yeah, it needs more time to boot. Give it 3 seconds. Oh. Well, now we're seeing the file system scan. So yeah, just for like reference here, let me get a cursor up. So this is the moment we hit reset, or the moment we come out of reset, I think. I think it's the moment we go into reset, but at this time scale, the reset's pretty small. And then here's it booting, and here we are, 1.6 seconds after reset at this particular underclock. It starts reading the SD card. And then very soon after this, when we give it the right file name, it's going to end up stopping. I wonder what this was. That particular trace, we didn't have all the triggers we usually would. Interesting. So anyway, and this goes for, as you can see, 3.3 seconds, which is how long the period is on the reset. I think we want to actually go reset it after probably like 2 seconds. So then we can see it get through some of these scans, and we should see this cut short when we change the directory entry. But we're not letting it get too much further. So, period, 2 seconds. Yeah, I hadn't determined why some of these traces don't have all those triggers. It's like sometimes it reads the card and then immediately stops. That might be a periodic or like an infrequent bug. But these traces with all the D0 and D1 triggers, the D0 triggers are each indicating that it's reading one block, and the D1 triggers are one block that's part of the root directory. So I think we're just going to put this file name in here. It's upbm.bin again. So I'm just going to convert this to hex so I can type in the hex code. Okay, that is the thing that I'm typing in. Now you can see that completely different pattern, so cool. So now I think we want to trim the reset to be like right after it is stopping there, so that when it makes any additional progress, we don't let it get very much further. So yeah, that should be safe, like about, that's 1.6, call it 1.68 seconds. Okay, so it takes a couple of cycles to stabilize, and then now we're interesting. It's a little further out than I was expecting it, but can we crank that even lower then? 1.1 seconds. Oop, too low. That's about right. That's 1.25 seconds. Okay. So this is, I'm trying to kind of put a really tiny box around this experiment so it can't run away. So this is the moment where we should see it doing something else once we give it the next thing that it wants, which is probably going to be the file size. Let's turn these off. Okay, so I think the next step in this experiment is to start turning up the file size and see if that's enough, because I think it might just be looking for a minimum size. That would be the easiest thing for it to look for. I think it's beer o'clock. I'm going to throw some bolts for the cat and open beer. Hey, Tuco, you want a bolt? You want a bolt, Tuco? Such a little tiger. Oh, we had some bolts printing. I wonder if they're any good. Oh, those are done on the little printer in the back.
I'm gonna give them to me. I'll check them around.
Oh, yeah. I'll get them out from the printer, and then Brenda is going to play with Tuco. Oh, here's one that's on the floor. You can have this while I de-printer the other ones. Oops.
Thank you.
They're bright red so that we don't step on them quite as much. You want to man the camera? sorry.
There we go.
Nice.
Sodium in chat is speculating that Tuco doesn't seem to like these bolts. And then Ryan is saying, such an odd cat. Oh man, I don't know what this is, but that's a pretty extreme ping. Yeah, I agree. This cat's pretty unique. This cat plays fetch, and I have not seen that happen. I've heard other people mention that this is a thing, but this is the only cat I've seen do it. Oh, I already started the printer printing another plate of red bolts. Maybe I should have tried a different color.
Well, we are saturated with red action. I just throw them all at once.
Yeah. I'm not quite sure how sensitive Tuco is to the color of the bolt. Like, he certainly likes some kinds of 3D printed bolts and not others, but I haven't narrowed it down to whether it's the color or the print quality or the smell or the taste or anything like that. I used a really slow retraction speed on these prints, partly because I was having trouble with the filament grinding on this printer, but that ended up making them really devoid of stringy stuff, which I think Tuco doesn't like the texture of. So I think as far as print quality, they should be all right.
It's
And
too
I
fast.
printed them with like 40% infill. Oh, Kyle is heading to the Swiss Alps tomorrow. That's pretty awesome. The turducken exploit. Yeah, so many interesting hacks that Travis has been responsible for. Oh yeah, and then Sodium suggests maybe it's the sound. Yeah, these do sound a little bit different. They're similar, but I'm wondering what parameter I should try experimenting with. Oh, you know, I can go turn the flow rate up on this printer without having to stop the print. Maybe I'll do that. The next batch will be 20% more dense. See if the 20% denser bolts have a better sound. Oh yeah. In chat, Sofa King says make a catnip infused PLA. Yeah, there have been a couple of suggestions to make like scents or flavors that cats would like. And that's been something that's almost tempted me to try to make my own filament extrusion setup. I think if I do end up with making my own filament extrusions eventually, it'll probably be for a cat-related reason. Well, I think at this point, let's stop stalling and see what we can do with this file size. I think it's ready. It's time to. Well, why are we not getting the triggers that we were getting? Is my experiment stalled? Let's make sure this experiment is working and then make the next change. This is a little weird. Not getting any of these SD card triggers anymore. Oh, you know, I've had this problem before where I'm running one of these experiments and the SD card emulator ends up getting into a wedged state. And in my other harness for this, the word list one, every time I reset the victim, I also reset the SD card emulator. But I think right now if I just press capital R myself, I can reset that manually. And we'll see if that helps. It looks like it is. It looks like we're getting more reads. Let's see what the next... Oh yeah, that did it. So it just looks like something we're doing is crashing the emulator every so often, which is annoying, but not necessarily a problem. I think this is still an alright setup. So if it gets wedged, I can press capital R, which will stop the clock, stop the SD card emulator, reset everything. But otherwise, I've got the oscope sending the periodic, like 1.25 second reset pulses, which at the very least make sure that this doesn't get very far. So I think this is what I want. Oh man, I'm sorry some of you are having problems with the video streaming. It looks like maybe YouTube is having some bandwidth issues today. I wonder if some of it is due to the video quality, because like, you know, Twitch and YouTube, one of the big differences between them is that Twitch usually just rebroadcasts exactly the bits that you send them, whereas YouTube transcodes everything. And so I send YouTube a pretty high bitrate stream, just like whatever I can, you know, bother to compress on my end. But then, like, I'm wondering if maybe they don't always detect the amount of bandwidth available on your end correctly, and sometimes they end up just downloading a stream that's higher bitrate than what's available. So I wonder if there's some way to get debug info about that. Like, I thought I remember seeing something in the YouTube player, like if you right-click on it, you can get info about which streams it's using and what the kilobits are, and averaging how much data it's actually getting through and that kind of stuff. Well, it looks like after that last couple of resets, now it's pretty stable again, which is fine. So this is our directory entry. Right now we've got the file name upbm.bin. This next byte is the file type, which right now is just a normal file, so that's good. Then we've got a bunch of unused stuff and some timestamps and stuff like that, which is less likely to be interesting. These two bytes are the file cluster number. So this is actually where it is on disk, which shouldn't matter too much as long as it's a valid cluster, which this should be. And then these 4 bytes are the actual size. So actually, I made some doodads in here to make it easy to deal with numbers. If we take a look at the source code for this hex editor, let's go to GitHub to remind myself what the keyboard shortcuts are. There should probably be a help or something for this. But in the common code, I've got this hex editor, which has some weird features, like you can have a cursor that spans multiple bytes, and then you can increment and decrement the bytes as a single number. So yeah, if you use the square brackets, you can expand and contract the cursor. But then if you use the curly brackets, you can change the size of the data items within the cursor. So here, for example, I've got this cursor on the last 4 bytes here. And so if I pressed increment here, now they're all 1s. If I look at the scope trace, it looks crashed again. If I manually reset it, what happens? Oh, is that getting further? Maybe that was all I needed. Maybe it was just checking a minimum size, because now it looks like it's getting into an entry that isn't the directory. So maybe I don't even have to illustrate my next point, but what I was going to say is if you press curly bracket, now you can start linking some of those bytes together. So now this is incrementing as 2 copies of a 16-bit number. If I do that again, now it's incrementing as a single 32-bit number. It'll take a while to get through, but let's see what happens if I set that to 0 again. So now it's stuck there. I'm curious what the minimum value is, because that could tell us a lot about the file format. Because like if we know exactly what the minimum size is that it's looking for, then that in relation to the size of the device's memory might tell us exactly how big the header is. You know, that seems useful. So a good place to start might be the actual memory size of this device, but since it's a bootloader image, that might not be necessarily it. Let's just go up by like 64K or so. So I'm going to go back to the smaller cursor and just put a 1 byte there. This is little Indian. And do a force reset. And wait for the trace to show up. Okay, so that's big enough. So now I want to set this back to being a giant cursor and try decrementing that until it's no longer big enough. So what if it's a little less than 64K? This might indicate that it doesn't have to be as big as the entire flash memory, because this device has more than 64K flash. But that it just has to be larger than some header. So actually, maybe this could be significantly smaller. What did I have it set to before? Let's start working on this byte. Takes a couple seconds to get the result. Okay, that's too small. That was 256 bytes. Let's try 16 times that much. Oh, that was big enough, apparently. Yeah. Okay, let's cut that in half. Too small. Still big enough. Is it going to be 800 maybe? I'm just really just doing a binary search by hand, looking at the file sizes. That's big enough. That's big enough. Is it just greater than 800 maybe? Oh no. Looks like between 810 and 820. 818. I think for simplicity, I want to make this file the minimum size that passes this test. So that's big enough. Is it 819, I think? I think that's our number. Yep, 819 is the minimum file size. So then I think we're just going to see it reading the first block of that file right after this. So it's cluster 100. Read address is 41 hex. I hate calculating this stuff. Actually, I'm just going to zoom into that data and read the cluster number off of the debug string that it's printed in there. Set up for SPI again. MOSI on D9, MISO on D10, chip select on D11. Clock D8. gonna work? Okay. So that one after the directory entry read is what we're really interested in. Oh geez, stop giving me different values here. Now my experiment is no longer giving me stable results. Reset. This is weird. This doesn't look like one of the normal data filler blocks that I usually have. Oh, I wonder if this is a good time to plug something like the Salier analyzer back in so that I can get a longer capture of this. Because I think this is slow enough for the Salier to keep up. Let's see what the clock frequency we're dealing with is. Oops, come back. Come on, scope. There we go. Oh, once I zoom in and farther than that, I run out of buffer space and it's changing the delay. That's why I get not what I wanted, but I can still do it this way. I mean, I think this is going to be fine. I just want to measure it to be sure. Yeah, that's like 1 megahertz. This will be fine. So let's get the Salier on this. I think that might actually give me kind of the deeper capture that I'm looking for right now rather than what I'm getting on the scope. So I'm just going to unplug this to make this a little easier to deal with. I think we're not necessarily going to be looking at the analog stuff at this point. I think my Salier is in my luggage too. Grab that. Oh, that's interesting. So it looks like YouTube is kind of sending some crazy high bit rates for some people, like 11 megabits. So I do upload at like 12 megabits here, but that's just because that's the crazy high bit rate that I use as input for my own editing stuff later. And since I'm encoding that anyway, and I've got the bandwidth, I'm just sending it to YouTube so they can re-encode it for people. But it looks like sometimes they overestimate how much bandwidth the client has. I don't know. Does it give you an option to change the, like, what bitrate stream you're receiving in the advanced options or anything? let's get this on SD. Oh, I'm seeing a couple of people in chat saying they'd love to see a 4K stream. Yeah, that would be nice. I mean, I have the bandwidth for it here, thankfully, but I don't think I have any 4K cameras right now. I'd have to like get all new cameras to make that work really worthwhile. I mean, it might be nice to have a 4K camera on the Tuco robot, but that also just makes the video distribution even harder. I mean, it's enough of a challenge right now to get 1080p 30 FIPS with low latency. So, I mean, yeah, 4K is out there, I'm sure eventually, but right now I'm enjoying how inexpensive the 1080p hardware is. Yeah, and Thomas adds, quality at a given bandwidth depends greatly on how you encode it. Yeah, definitely. And I don't necessarily spend a ton of CPU encoding like a really optimized stream for the real-time stuff. Like I basically don't have the CPU time to do that. All of my real-time H.264 has to be done on GPUs pretty much. So it's not necessarily as good as a really good CPU encoding, but you know, for stuff that I'm editing, it gets recompressed again anyway, so I want a pretty high bitrate input to that, even if I can't spend the time on, you know, compressing it down a lot. Use the top half of this analyzer for triggers and the bottom half for the SD SPI protocol. Yeah, I mean, some of the, like, as for 4K cameras, like, you can get, like, you know, consumer grade action cam kind of stuff that's 4K now, but, like, the thing is, for most of what I'm doing, it is significantly better if I can get the recordings to go directly into some kind of PC that can, you know, store them directly onto a file server instead of having to go through the whole, like, SD card thing. So I still do that for my digital SLR camera here, but, you know, it's much nicer much nicer whole process here if I can, you know, like SDI, for example, is actually really nice because it's not going to kind of have mode disagreements like HDMI is. It's one direction, you can easily split it and switch it without having both ends get confused. I mean, I think I'm guessing that like UPBM is something like update boot manager or something like that, but like, you know, yeah, I guess that's exactly what Nicholas just said in chat, but yeah, I don't know. I mean, I think with a 4-character file name, we're not necessarily going to learn that much about what's in the file from the name, but it's a nice thought at least. Do I have Salier on this machine? There sure is some sunlight in my face. It'll move in a sec. Oh yeah, Code and Solder in chat says the first time they've seen a genuine Salier used. That's funny. Yeah, I mean, I don't know, it's weird, right? Because like clearly they put a lot of effort into the software, but like it's also kind of a weird move to make a product where you know the hardware is going to be really simple and people are going to copy it, but you have to secure it by making the software kind of its own thing. So I've been meaning to try out more of the open source logic analyzer tools because I want to know more about, you know, what they're good at right now. How fast can I grab all the signals? Do I need all those? I think I don't need the top half of this. I don't need these or these. 32 megasamples it is. Okay. So is that looking like anything yet? Oh, we should get reset on here maybe? Well, I don't know if we need reset, but we do need to issue a reset because we're not getting any of the usual triggers that should be showing up on those channels. So reset and start recording. And, well, I guess I don't need the scope right now other than as a signal generator. Okay, so here's some good resets. This is the directory entry with a bunch of copies of that experiment. Why are we not seeing clock pulses here? Oh, I think this is just labeled wrong. Yeah, this is obviously labeled wrong. This is just, that's right, this is just how I had it set up in a previous experiment. Let's get rid of that. Why is my phone buzzing? Go away, phone buzzing. Okay, clock, then MOSI, so SDS, and then the rest of these are triggers. This one is any block. This one is a directory entry block. Just watching this counter tick a bit to get a couple of reads recorded. I'll go back here and stop it. Oops. Okay, how is this now? Oh, why can't... This is the perennial problem of logic analyzers. Why can't it show me the information I need when I'm at a reasonable zoom level? Just wasting so much space here. Anyway, so this second line here should be our directory entries. We should see eventually, yeah, that's bin. There's upbm, so those are file names. Should see a bunch of copies of that. Now, over here, this is the next read. This is returning all 255s. What is it trying to do over here? Please show this in hex. That's the block number, 82. Is that the same thing I'm seeing over here? 41. Oh, right, because this is bytes, not blocks. Okay. So yeah, that's fine. It's just not... I was expecting this to give me my little text indicator that showed me where I was in my actual file, but did I remove that from this experiment, maybe? Yeah, see, this is what I was looking for. If this was actually the file data block, I would be expecting it to give me this pattern with Z's and then the cluster name, but instead we're not really. So maybe this is some other part of the file system we haven't implemented. So address block 41. I'll just have to calculate where that actually is. Oops. Okay, so this is in common code that implements the FAT file system. And we're going to need to do a bunch of translation on this address to figure out where it actually is in the file system. So this is the block 41 hex. If we look at the actual switch here that figures out what to do with each particular block, we would need to figure out like what does this actually turn into. So LBA is 42 hex. And I would expect it to be after the root directory, so after fat root end. But let's figure out what this actually is. What does fat root end actually come out to? Oops, that's not what I wanted. So partition start is 3F. These are our sectors 1. And then the size of the file allocation table. Table start, yeah. Sectors per table times num tables. So we have 2 tables. And then each table is OX3E. That gets us to the end of the file allocation table. Then we have the root directory, which is OX1000 over 16. That's 1 BC. You know, I wonder if it's calculating something incorrectly because of the really giant root directory we gave it. Maybe I try changing this back to a reasonable number and not 1000. I think OX200 is still within the spec. I forget what the actual restrictions are there, though, for FAT16. It's reading C7 or C8. Okay, that's default bin. Let's change this again. Where's my hex version of that I calculated? It's my UPBM. I guess I can make that the default now that it seems like what I want. Okay, now it's reading BC. Let's get another trace with a reset and a couple of file reads. Yeah, I wonder if maybe I was overflowing some calculation that it was doing in an 8-bit variable. That's interesting. These seem to be stopping at the directory entry and not going further. Oh, that's right, file size. Oh, geez, what was the file size we came up with earlier? That was like... I really should have written that down. I mean, I know I've got this on video and I can go back through that. Let me put in something larger. Actually, that file size is already quite large. Let's just try that. 64K again. With a reset and trace. That's what I wanted, I think. Block 8.2, which is what we were seeing over here. Yeah. Oh, It's the same address, even though I changed the size of the root directory. It's interesting. I want to reset this just to make sure the experiment is in a good state, but first I'm going to change this so that it makes the guess that I want the default. So up BM, and then here's the size. I'll just set it to that for now. This should get us back into that state where it's reading the block we care about. Oh, I wonder if this is a build system thing, like maybe it didn't recompile that common fat layer. Do that. Okay. Reset again. Address is 41 again. Huh. There's the directory entry. And here's the next thing, mostly ones. That's block 41. Oh, is this the file allocation table? No. Okay, just for reference, what was the block number we were in over here? I think that's... Yeah, that was much earlier, I think. Yeah, this is just a weird number because it's a byte offset, and so this is the least significant byte. This is the most significant byte. And so when you actually divide this by 512, this turns into 41 as a single byte. But that's the number we're looking at right after the command. This is the read command. So 8.2, and then we just have all these. Does that change at all when I change the cluster the file name is in? Because, I mean, this might just be like a fat implementation bug on my side. I'm just looking for the next way to debug this, and I think I'm just going to try changing this number right here and see how it responds. I think if this does what I expect, I would expect to change, let's see, this number right there, and I would expect to see this read address change after the experiment finishes running again. So I'm just going to try bumping this down by 1, and run this again. Okay, and it bumped down by 1. So I think we're just disagreeing about where the files actually start in the file system, which is probably just me implementing the fat header wrong somewhere. Oh, I didn't want that to be linked. Can I set that to 0? Is that allowed? PC. I think those first few clusters were supposed to be reserved. Yeah, I'm seeing just 40 again. Let's reset this. Okay, 41. Okay, this is a little endian number. This is 0100. If I increment it, I should get 42. Is that right? Reset. Some reads, still 41. Maybe it isn't related to the cluster. Maybe I just got a different result when I made it too small because I was hitting the reserved part of the fat. Yeah, I mean, it kind of doesn't look like it's actually trying to read the file contents yet. This might be some other header, like maybe something part of FAT32, or something that I already have but isn't implemented correctly. Let's make sure this is still running by doing another logic analyzer trace. Yeah, still looking good from the incrementing counters at least. A2, so where would that be relative to everything else in the fat? A2, come on, what you doing, little guy? Well, I mean, we could also try changing the layout of this file system if we wanted to. We already tried changing the max root entries, but I don't think this has to do with the actual root directory. Or do one. I mean, it feels like it's probably the file allocation table. Maybe it's looking for a chain of clusters in the file allocation table and not finding the ones it's expecting, and then it's giving up. Oh, 404 in chat is asking who the mysterious person in the background is. That's my friend Brenda, who's been visiting. She shows up every once in a while to play with the cat. Yeah, so I mean, the file allocation table layout is confusing the way it's set up right now, but I think this is actually part of the FAT, and because that would explain why it's returning all FFs, because that's what it's programmed to do right now. And that indicates that, so the FF in FAT16 would mean that that cluster, so in this case a cluster is I think 4 kilobytes, so that particular 4 kilobyte chunk of the disk is in use, but not connected to any other 4 kilobyte chunks. So I think I just need to Sitemaster says in chat, there's a bug with your cat bolt cannon. It's just sitting there watching stuff. Well, you know, cat bolt cannons are hard. There's so many solutions to the problem, but, you know, I think it's going to take a while for us to find something that is that satisfies all the constraints of being, you know, triggerable remotely and, you know, something that everyone has fun with and won't hurt Tuco. But that's a project we're working on. So I think what I want to do is maybe just set up a little run of clusters that is a plausible size for this file, if I can do that. Let us make sure that our tree here is not too gross. Oh man, I actually kind of wish I had written down that file size that I calculated. I'll go back and look at what it was in the stream, but I think it was something like 813. Oh, maybe I can just try that really quick, because I kind of want to put that in this program too while I'm at it. So we run that. BC. No, that's not big enough. Okay, anyway, I'll find that later. But so BC is, so that's the root directory then. Definitely the stuff before it is going to be the FAT. So how big does it need to be? We know, I'm just trying to think of it in terms of clusters now instead of bytes. So we're still dealing with these 4K clusters, which would be 00. That would be like 4 clusters. Not big enough. Thought 16 clusters was going to be big enough. Yeah, let's just do something like that. Okay, so I think if this is the FAT, then as we change the cluster number, that will actually tell it where it's reading in the FAT, but it isn't going to be going up by entire sectors. When I change this by 256, it'll move the address by 1. So I think we should see that if I increment this number, we'll see it reading from 42. Yay, okay. That must be what I did earlier when I thought this must have been reading from the file, but that must have been 2 mistakes combining together, because I don't think I noticed I was moving the most significant byte instead of the least significant byte. And if I set this to 0, it should be the beginning of that FAT page. So yeah, I'm going to add a special case for this particular cluster, or this particular page or sector in the FAT to tell it to just chain together a bunch of clusters, and we'll see if that gets the firmware any further. So oh, that's right. I already have that actually. I have it set to call this fat table entry function. So I think we just need to edit this, perhaps. Actually, I need to remember how the chaining works in fat, so maybe this is a Wikipedia break. This one. The actually technical article about this. So it's something like this. Yeah, this is just the little endian index of the next cluster. So if we just set these with an incrementing pattern, then that'll at least tell the file system driver, hey, we've got all this space allocated, that's where you're going to be reading from, and it should let us make some progress. Yeah, so let's chain them within each page. So, okay, so this doesn't. Oh, is that the cluster within the sector? Does it not? I'm trying to remember what my own terminology was here. Okay, yeah, that's just the overall numbering here. I will want that, though. So this will be cluster plus 1, unless I'm at the last one in the page, I think. Let's do this. Let's make a bool. Just having this detect if it's the last one in the sector. Sectors per table. Is that right? So sectors per table is... Oh, okay, so this is just so that we can get 2 copies of the fat, I see. So... Oh, okay, this should just be another constant to be less confusing. This fat entries per sector will just be block size over 2. I mean, this for FAT16, this is always 256, at least on a 512-byte block machine like this. Sure. Entries per sector. Okay, so that's one way of doing it, which should work. And then So if we're last, then we end the chain, otherwise we chain to the next one, creating a little linked list. So let's see if that gets us further. Oh. Need to import our booleans. Did that not work? Did I not save that or something? Oh, I guess that works. Seems to be the same thing. Let's see if we're at least getting the new data. If we look at this in the Salier, we should see that new fat table that we wrote, if everything's working. Looks different. This might be easier to debug if we actually just dumped this block from our actual SD card reader. Yeah, maybe let's try that, because like there are other options for debugging this fat file system than staring at it in a logic analyzer. We can just connect it to a computer. So let's try that. Hey Tuco, what you up to? Where are you? Where's my SD card reader? Oh, here it is. Oh, I don't have that breakout test right now. Actually, this is slightly annoying. Just trying to remember how this is structured. So there's going to be a command here, then some blank space where we're waiting for the response. This FE is the token that comes right before the actual response, and then this is the first byte in the sector. So these 2 bytes are the FAT16 entry that should correspond to cluster 0100, which is where the file starts. And it's saying continue at that sector, which is 0101. That's actually looking right so far. Yawn. This should continue for pretty much the whole thing. I mean, it might be that now we've made the chain too long and doesn't like it. We've got an FF. This is the kind of last cluster in this particular fat sector, and we're just saying that's the end of the file. And that's the CRC16 for this sector. Oh, what's going on here? There's another command. This is a 51. Is that also a read? Maybe we are getting further, and it's just the reset needs to be extended a little bit now. I think that's a read of perhaps actually the file. Whoa. Okay, let's give ourselves a little more time now. So let's go to 1.5 seconds. And get another trace. Oh, we got a good cat pose up here. A little bit of sunlight hitting the lens. Oh. What is that? That is some noise. Maybe not. Because that's the directory entry read. That's the file allocation table, and I don't see another full packet. So maybe that wasn't the reset interrupting it. What is this command? 51. That isn't a block read, is it? I'm gonna go back and make sure I know what this command was. No, that one was 51, so that's the same command. So it's 51 and then 4 bytes of address in bytes. Why did it crash right after this read? Oh. Huh. What is this address, and why are we not actually reading it? It's like it's not waiting long enough. I mean, this... Oh! No, this is an error flag. Sorry. Is this past the end of... I mean... Which error flag is that? 04? Do I have the SD card spec on this computer? So, okay, just to recap briefly. So what we've got so far is we reset the machine, it's booting over here, then each of these little spikes here are it requesting one block from the SD card. So this first one is probably the master boot record, and then this next one is the root directory, and this is where we've been sending the file name a bunch of times. Or sorry, no, this one's the root directory. We've been sending the file names. So just to be clear about the order that this stuff happens in, these are the actual file names. This is the trigger that says we just finished a directory entry. So the triggers happen at the end. So this is when we were sending the master boot record. This is when we were sending something else, probably the fat file system header. And this is sending the directory. And this is sending the fat allocation table, so the actual file allocation table proper, at least the one sector of it that we want. And then we're getting to the next read, but we're getting as far as a command. So this 51 is the actual read command, then here's the address, but then our SD card emulator is actually rejecting it with this error code here. So I want to figure out why that's happening. Aw, Microhex in chat says, feels like the stream of people discovering Micah's streams is increasing. Well, you know, I hope if there are more people that like these that they can find it. That would be nice. Do I have this on this computer, first of all? Or is it easier to find on the interwebs? Probably the latter. This is where you go to find out how the SD cards actually work, at least as insofar as you can without paying them the big dollars. Look at all them terms. So, and we actually want, Chapter 7 is on the SD card protocol, and there's a specific response format that tells us what those bits mean. I don't think this has an index either, which is annoying. Let's at least not view it in Chrome. Yeah, why did they say confidential? It was probably in the terms and conditions somewhere. They don't have time. They put the time to put that on, but no table of contents. Thanks, guys. Anyway, chapter 7. I think we're looking for the definition of the R1 byte. I mean, it's almost easier to read this from my own Verilog source code, but I think this is potentially more instructive. Here we go. This is the basic response that we get from any SPI mode SD card command. So that 4 means illegal command. Why is it an illegal command? It's a read. Yeah, these are it waiting for our response. This is our response. This is the actual command, which is an apparently normal read. Is anything different about this versus the previous command? Let's wait for Celia to page in. Oh, took removed again. Yeah, so we might have to dig into the hardware and take a look at what's actually going on in here. Oh, neat. Apparently 4 a.m. and Quinn both tweeted about my channel recently, and so maybe some people are here because of them. Well, hello, welcome. Yeah, the confidential in here is definitely a joke when like anyone can download it from their website. So let's take a look at the hardware and see where this might be coming from and why this might be, well, I was actually going to look at the capture before I prompted Celia to like, what even just happened? I think I somehow got it to just page out my entire experiment. Is it this file? This one's really old. I think I can't make 2 copies of this, can I? I'm just trying to have 2 different windows so I can compare to 2 different parts of the same trace. Just like one of those basic UI things that would be nice. So I can't copy this window, I can just copy the settings. Alright, well, what I can do is take a screenshot. Tuco, how did you just reboot my Mac? What did you just... Were you sitting on the power button? You're such a weird cat. Okay, so here's the one that failed. Let's go to the very previous command just to get a side-by-side comparison. Same reads, different address. same timing, it seems. Oh! Oh! What? This is not a sector-aligned address. Yeah, no, I think this is the problem. I just saw this. This is not divisible by 512, this number here. That I can tell that because the low bit in this number is set. This being an odd number means it's not sector aligned. Well, that's annoying. Because basically this emulator is designed to work with sectors, which are usually 512 bytes. And if you're working with the SD card high capacity standard, which is I think anything over 4 gigabytes or 2 gigabytes, then it has to use sector addressing. Like, you can't address in bytes anymore because that just won't fit in 32 bits. But in SPI, well, no, it doesn't have anything to do with SPI mode, but for hosts that don't advertise support for high capacity mode, you still represent things in bytes. And so I added some translation such that most of the interfacing in this emulator core still works with blocks, but at the level of command parsing, it converts things back into block addresses if they're in bytes. So I think we're seeing the bad command bit here set because the command parser is like, whoa, I don't know what to do with this argument because it doesn't fit in my world. So fixing this properly is super annoying. I'm just going to hack this so I can move on because I don't actually care if this is reading the correct data. I'm happy to just throw away that bit and then just munge my addresses accordingly. But that's weird. Why would it be doing that? And is it legal for me to just throw away that bit anyway? Because it shouldn't be starting to read in the middle of a sector. Yeah, let's think about why it might be doing that while I'm also hacking around it. So, hacking around that will involve recompiling the FPGA, which takes about 5 minutes. It's not in the software directory at all, because this is not software anymore. Alright, so this is in cores. There are a few different pieces here. There's some kind of add-ons for just the triggering and just the timers. There's the kind of wrapper around the low-level Verilog code, and then there's the actual Verilog code. So I think, unfortunately, everything that we want to do is in the Verilog code instead of in the Python code, which is a little bit less nice to work on, but it's fine. Just for reference, the Python code looks kind of like this. Let's get a little bit bigger window here. Yeah, I don't know whether Tuco overheated it or just laid on the power button. Because he is sitting like right where the power button is. I think he might be pushing it. And I don't know if he would overheat it, because this isn't where the fans are. He isn't blocking the fans. And I think he would just be acting as an additional radiator for the laptop's warmth, because the laptop is hotter than he is. Like, he would be getting warmth from the laptop, which is why he likes it in the first place. But I think this is self-regulating. If he turns off the laptop, it's no longer going to be warm, which means he won't like it as much. Oh yeah, Len says, I like it when he changes the stream title. Yeah, that should be a thing of the past. For a while, I had this little, there's like a little Surface Book that I'm using to do the chat, and I had that on this little side table before, and Tuco would sit on it and change the stream title. But right now, I don't have a keyboard on that machine, so it doesn't really do that. Oh yeah, so Garaza in chat says, maybe the bootloader tries to skip some headers in the UPBM file and then go right to reading the data. Yeah, that's the. I was starting to realize that too, and that's the only explanation I can think of that makes sense. But I guess it has me wondering whether that's the explanation or whether, you know, maybe something else is going on that means I should be ignoring that bit for some reason. But yeah, I mean, this could tie in with, you know, we were seeing earlier that there is a minimum length on this where it doesn't even try to open the file unless it has that minimum length, and that gives us some hints as to what the header length is. So yeah, it could be trying to skip the header and read that into memory, which is weird, because if it's going to have such a long header, why would it skip it? But maybe it's going to come back and read it later. Like, one thing I was thinking about with this is if it does do some CRC calculation or signature calculation, and if it does that before reading the firmware or before programming the firmware, there's not a lot of way for them to get around reading the firmware multiple times, because I don't think it fits in RAM. So they would have to read it once to calculate the CRC, then see if it passes, then read it again. So that opens some interesting avenues, like what if the CRC algorithm is really annoying? Maybe I just send a file that's like all zeros and give it whatever default CRC it wants, and then next time it reads it, I send it the actual contents I want. Because it's not going to have memory to cache this stuff. So that might be interesting. But yeah, that's a good suggestion. I think we will come to figuring more about that out quite soon. But I think for right now, I'm just going to try to get a little further by ignoring that bit. So yeah, this is some of the code. This is Python code that generates hardware using this mygen module for Python, which is pretty neat. This is the lower level wrapper around the Verilog. What we actually want right now is actually the link layer implementation in Verilog. I think I just want to search for, I think I've got a state bit somewhere that tells us whether this is high capacity capable, and that would lead us right to this new code I added. Yeah, host HC support is something I added relatively recently to this, so let's look at where that's used. Oh, actually this. So command inarg block adder is where I do the translation. So this says high capacity mode uses blocks natively, legacy mode uses byte offsets, so they're converted here. And so this just checks this flag, which we set according to whether the host tells us that it knows about high capacity mode when it's initializing, and then it either chops off some bits or doesn't. This isn't what generates the error, though. So the error is going to be elsewhere, but also probably still computed using this flag. So let's just look for this still. So here's where we detect it during command 1 and a command 41. Huh. Is it neither of those? Where does that error actually happen then? Would it possibly be in the phi layer? No, I don't think the phi even knows about this. Maybe let's work backwards and look at that R1 byte and see where that error bit gets set to remind us how that actually happens. Here's that response. Well, that's it being cleared, I guess. I've probably said this before, but the code that you're writing for doing these kinds of hardware modules often ends up getting really splayed all over the place. So you have, like, for one particular feature, you have code over here to update states, you have code over here to clear bits, you have code over here to form the response, you have code over here to, like, accept inputs, and all these different tiny little machines working in concert. And you get some nice higher level abstraction tools with mygen to kind of centralize some of these issues a little bit more. Anyway, I think the actual responses get built in the phi layer. Maybe not. I'm already forgetting how this code works, and it's only been like a week since I've been in here. Oh, here's the SPI status word. Okay, so we're seeing this. Whoa, no we're not. We're seeing this, stat illegal command. response bad is one way to get here. Is that the only way to get there? Maybe. Okay, so response bad is just one of the states we can get to in the response state machine. Oops. Okay, so that's just going to be like the default in case if the state machine here doesn't actually end up taking some appropriate action, then it goes into that bad state catch-all. So we're looking at block reads again. Read single. Oh! Okay, this is a totally different problem. This is just a bug in my hardware. This command in arg is checking to see if the block is out of range. And so this is just the case that if you interpret that as a block number, then it is out of range. If you interpret it as a byte, it isn't. So I just need to change this to use my macro that calculates the right address. So actually, a couple of these are going to need changing, the whole command in arg thing. So let's remember what this thing was called. Yeah, command in arg block adder. So any place where we're using command in arg as an address should probably be changed to this version of it. So it's none of these. So really just like the read and write commands. So this one, read single, which is the one we were failing on. This one, read multiple. Oh yeah, so I did change this down here when I'm actually setting the read address. I just forgot to change it up here. So that's the bug. Same with a write multiple. Erase, maybe? These have different errors, so I don't think I'm going to worry. Oh, this though. Block adder. Those are all for different stuff. This is back in the territory of stuff where those aren't addresses anymore. Okay. I think those are the right changes. I think we just need to resynth the hardware and see how much further we can get. Let's make clean and do a fresh build. So yeah, this will take about 5 minutes to recompile the FPGA. Oh yeah, so Pakakezu in chat says the header skipping would make sense if it wants to calculate some form of checksum, then compare it to the checksum in the header. Yeah, I'm actually kind of hoping at this point that it's going to read the file multiple times, because then that would give me an opportunity to give myself an easier file for checksumming and then a harder file for actually programming in. I mean, I don't really want to write to Flash. I kind of really don't. The thing that I, like, just to back up a little more and have some context, it's looking like what happened when I bricked it was that somehow I wrote a bit into Flash that causes it to default to booting into the bootloader instead of into the actual application. So I'm still having trouble conceptualizing exactly how that could have happened, but it does look like what happened was I wrote to Flash somehow, and I probably disrupted some small portion of Flash that tells it. So either I just cleared everything, or I disrupted, well, everything except the bootloader itself. So that's already a bit unlikely. Or I somehow disrupted just a portion of the Flash that it uses to figure out whether it's going into the bootloader. That also seems kind of weird, which makes me wonder if maybe this is stored in a separate area of memory. Like maybe there's, EEPROM or something for this. Milan in chat says that they want to send me some IR sensors for donation. Well, thank you. I don't have like a link for that on my blog yet, but I should set up like a PO box for that sort of thing, but for now, if you send me a Twitter DM, then I can send you an address that you can send stuff like that to, and thank you, I appreciate that. And then Dark Samus is wondering what's going on. Well, since I'm waiting on the compile, I guess this is a good chance to give a slight recap. So this is still working on the experiment where we're trying to unbrick this PLC, or at least get some good information from it while it's bricked. And so this is something that happened during an earlier voltage glitching experiment. The exact means still a little bit unknown, but it's probably clobbered something in flash memory such that it's got stuck in the bootloader. And so now when I boot it, it's going through this sequence of steps where it seems to be looking for some special file on the SD card. We don't know anything about that file. And so this experiment is basically using side channel analysis and some brute forcing, trying to figure out what it might be looking for and getting it to make more progress in this so that we can maybe use that as a way in. So far, the brute forcing has revealed the file name, and we've also figured out how big it has to be at minimum, which I then proceeded to forget to write down, but I can go back in the stream video and find it. I think it was around like 16 kilobytes or something. But yeah, it was not necessarily something that sorry, I lost my train of thought for a sec. I wouldn't expect that to be the full size of the firmware. I would expect it to be the size of a header that it's looking for. Since the actual memory on this device is somewhat larger, I think it's got like a megabyte of flash. So yeah, it's looking for this file. We've managed to brute force the file name using this flipsyfat tool and figured out roughly how big it needs to be at minimum. And then the next step was it was looking in the file allocation table, and I think it was giving up because I'd built a fake file allocation table that just has every cluster as a single cluster file, and it was failing at that point because it was expecting to see a longer file that it could open. So then I modified that so that every sector's worth of file allocation table just like links all the clusters together in that sector to make a big file, which was an easy way of giving myself fake fats for testing. So that's getting it further yet. And then I was hitting a bug where it was doing a read, and before even getting to the software, it was hitting a hardware error where the hardware was rejecting the command with an invalid parameter error, or like an invalid command error. So that's what I think I'm solving now by recompiling the hardware. I found a bug where it was just comparing the wrong value, where when it implements the block read, I have this other version of the address that gets computed as a byte address with the proper translation, or as a block address rather, with the proper translation if it's in block mode or in byte mode. So that's in there now. I just didn't have that implemented everywhere it needed to be, and so there were a couple of places where I was comparing the byte address as if it were a block address, and then I was reaching an like end of medium error, like it thought the address was too big, so it responded with an error. So we're almost done. We're actually programming this into the FPGA, and then I hope we'll see this no longer responding with the same error. Hope we can get a little further. And I still have the O-scope sending a reset signal now it's 1.429 seconds. And that's just kind of as an insurance policy, so this doesn't get very far, even if we start giving it the things that it wants. I don't want it to actually make enough progress where it starts potentially erasing stuff on the chip. Oh yeah, also, if anyone isn't aware, these Senrio Lab streams are all on Twitch on the Senrio Labs account. So yeah, if you're viewing on YouTube and you're having trouble with YouTube, like that's certainly an option. And if you're here on Twitch, then hi, more people can join you too. Yeah, all the Senrio stuff gets streamed out on both services right now. Okay, so let's actually put the software I wanted back on. It was just loading like the simple example because that's what the top level make file does. Entry prob. Okay. So that's all set the way we want it. Well, except for the file size. Yeah, well, okay, the file size is big enough. Let's just see how far this is getting in the actual Salia analyzer here. Start that recording, then do a fresh reset. And we'll watch it do a few blocks here and then stop it. Okay, so here's a few. Ooh. We're getting a new trigger here, channel 11. I think maybe that's a file block. So, okay, so where are we at so far? This is the directory. This is the file allocation table. I think this is the actual file data block. Yeah, let's get this in ASCII. I think this is trying to tell us something. Zero, 1, 0, 1, plus 3. Interesting. So it is not reading from the beginning of the file, it is reading from a weird offset. So that definitely would seem to indicate that it's looking for a checksum first thing, or some kind of header. Oh, interesting. Thomas in chat says that they're getting an extra 10 seconds of latency on Twitch, but Nicholas says they're only getting a half second. That's interesting. There's a little bit more machinery on my end for Twitch because I've got an FFmpeg transcode, but then I think there's less machinery on their end, so I would figure it would be mostly the same. So this is saying 101 plus 3 cluster. So what does that actually mean? This file starts at 100. So this number up here is the first cluster in the file. A cluster is 4 sectors in the current FAT organization. So I don't want that screenshot. So what this actually is saying is, 1 times number of clusters, or number of sectors per cluster, plus 3. So we're at an offset of 7 times 512, or about 3,500 bytes into the file. Which is interesting. I mean, that might be the start of the actual firmware image, and so it's reading it to calculate the checksum, then it'll come back and look at the header. That was what I padded most of the block with because it gives me a nice alternating pattern in 4-bit SPI. So clearly something in here it just didn't like at all. So if it was calculating a CRC and just reading this as a firmware image, then it would just be reading a fixed size chunk of stuff. It wouldn't care what's in it. So this is both a header and not at the beginning of the file, which is a little unusual. It's also not 512 byte aligned, which is something my current hardware is totally ignoring. But that bit is still a thing. So, I mean, it's actually not just that times 512, but I'm sorry, it's that plus OX80, or no, not OX80, but 256. Oops. What did I want to, man, I'm still regretting not remembering what the name of that, or what the file size was, but I think it was something along that line. We can try changing the file size in the neighborhood of this value to see whether that might tell us what the length of the structure it's trying to read is. Because if it is trying to read like a fixed size header, maybe this number tells us where that starts, and maybe the minimum file size it's looking for tells us where it ends. Oh yeah, Dark Samus is a good question in chat. They're saying, so the SD card is always in SPI mode? I find it odd that most stuff uses that rather than native SD commands. Yeah, so a lot of it is just that the having all the IOs be byte aligned and not having to compute parity and stuff like that. Like the changes that they've made between SPI and SD mode, they don't really change the commands much. They really just change the parts that are annoying to implement with a regular SPI. Like you can implement SD with some microcontroller serial peripherals, just not necessarily all of them, and it's often a lot of work to shoehorn something that doesn't really want to implement SD into being an SD controller. So that's, as far as I understand, the main reason that they have the SPI protocol. And yeah, I mean, it mostly just turns out to be something that is simpler, but not necessarily like as fast. Yeah, Dr. Toon is saying that you can clock it at 25 megahertz easily. And SD, I think, the high-speed SD mode that I usually see devices using, well, SD has a bunch of different speed modes, but there's like, I think the basic mode is like 25 megahertz, and then the first mode up from that my emulator is usually running at is like 50 megahertz. Yeah. All right, I think I'm starting to run out of energy for working on this particular project. Since there's definitely work to be done in figuring out what parts of this it cares about. But I'm feeling like maybe this is an opportunity to think about giving myself a little bit more leverage, because this might be something where I can come up with another experiment that I can run in a pretty much automated fashion that'll give me the information I need for the next step. I do want to figure out, okay, I'm just going to try a couple of file sizes around here to see what that does. Yeah, what is 3840 in hex? Oh, that's F00. Yeah, okay. Foo. Reading a block from foo. So, the easy way to run this experiment here is to press capital R and then watch that RDA. So that large number there, that 4 dB, indicates that I'm actually reading from the file. But if I were to change this to something too small, now we should see it get stuck at the root directory. Why is it still running 4 dB? Let's reset that again. Where is that coming from? Is that still big enough? Hmm. Zero byte. Definitely doesn't like 0-byte files. Okay. So maybe there was some interaction here between the file size and the cluster map in the FAT. And like now that the FAT cluster map is kind of maximally big, I might get more information out of changing this file size. That's interesting. Because now the file's only 255 bytes long. And if I reset it, it's still going into the actual file contents there. Interesting. So what if this is 1 byte? No. Doesn't like 1 byte. So that BC means that it's back stuck in the root directory. Another binary search then? Let's do 08 first. Too small. That is too big. That is too small again. Still too small. Oops. It's right around here. Okay, so this is looking for something really little. Remember, capital R is what I said. Looks like 1A is the minimum length. That doesn't really make sense. I mean, it's looking for something which seems to be at a much longer offset. Let's just test this again. So 1.9 and then reset, then wait for the block counter to increment, and the address gets stuck at BC. Then increment the length. Length is 1A now. I hit reset. Wait for the block counter to stop. Now the address is at 4D4. So 1A is definitely the minimum length, at least when the cluster map is full. Now I'm curious if, with the length set to something this small, if the subsequent read still looks the same. So let's just check that out. Let this get a couple of takes. Yeah, it's still reading from the file data. And I've still got that thing that is not sector aligned, that 0009, A8. And then we read it, we get the same little message, and then a bunch of the Z's. So, yeah. So that's interesting. So what we know so far is that it likes the file. It's willing to open it if the directory entry shows that it's at least 1A bytes long, which is a little bit weird since that doesn't seem to be related to where it's reading first. So that might be something that shows up later as a header. But then when we're actually, like, the first thing it does is it seems to read 512 bytes, or at least something that turns into that after going through the file system layer. But the important thing is that the read starts at this address 0xF00 since the beginning of the file. So yeah, maybe the next thing to do here is to I mean, I guess the easy thing to do would be to have this, to modify, well, I think I'm getting out of the scope of this directory entry fob experiment. I think I want to copy this and make a new experiment that's specific to this particular thing. So I think what I want it to do is let it read this one sector, then give it just a little bit of time so I can see what it does next, and then I immediately reset it and run the same experiment again. And then give myself a console for hex editing this block. And then just like there's a bunch of things that could be the right thing in here. Like, I think really to make this, oh, Tuco, did you turn it back on? What are you even doing, buddy? I think really what I'm thinking is I want another side channel because, you know, I start to make more progress and I'm not going to know it for a while unless I look at the power trace really. And the power trace in here is kind of okay, but well, maybe we should take a look at that. Maybe it's time to go back to the O scope instead of the Salier. Need this amplifier to go to the other board. Oh, neat. Wildmania in chat is doing some debugging on a little IP camera. Definitely recommend you check out their channel if you're interested in kind of, you know, like electronic streams, kind of meandering stuff to hang out with while you work. It's been nice. But yeah, the IP camera modules are interesting. One thing I noticed when I was shopping for the little camera for my mill was just how easy it was to find all these different modules in a similar form factor. They're all the same little square camera, but then some of them have Ethernet and some of them have USB. And I ended up getting one that was USB so I could plug it into a Raspberry Pi easily. But then I found out about the Ethernet ones later and thought, oh, that might have been useful. And then I think the one that I'm using right now that does SDI for my cat camera is kind of similar too. Okay, need to power up this amplifier. Alright, amplifier's on. I guess this isn't going to help much until I plug a few of these back in. Let's have D0, D1. I'm not going to hook up all these, I'm just hooking up the trigger outputs and a couple of the SD lines. Oh, I can already see some of that going on. So yeah, D0 is the any block trigger, D1 is the fat entry block trigger. I'm going to actually trigger the scope on these now that we have them. Scope on D1, and then I don't think we need to hold off anymore. Although 1 second of hold off is not going to hurt us in this experiment. That's 8, 9, 10, 11 for SD. Something like that. Chico knocked my phone off the table. Okay, so we've got this. What we're looking for is a power trace that is or any side channel that will help us determine when is it deciding that this block was no good, one that it just read. And so far this looks really bad, like my power supply is still oscillating. I think I might be lacking in low capacitance decoupling, like low inductance decoupling rather. I mean, this is 10 millivolts, but I can go a lot deeper here. This is like all pretty uncorrelated. Like we can approximate the signal we're trying to find by doing an average here and see how much of this is noise and how much of it's real. But I'd like to not have to do a ton of averaging for each of these experiments, because that would be a lot slower. So I think you can start to see what's going on. I'm going to back up a little bit and let this keep going. So basically, this is the side channel I want. I just want it faster and less noisy. So I think I'm going to try to clean this up with the addition of some more capacitors. Yeah, so you can definitely see there, it's got this sort of kind of bursty stuff up here where it's actually receiving individual bytes. And then here it's processing that packet, doing something. And then it kind of goes back to a lower activity level state where it's not doing much. It's doing maybe some periodic stuff, but seems pretty asleep, relative to this at least. And in fact, if we have a better power trace, we could go in here and maybe look more carefully at what the comparison seems to be and just look for this making any progress as we change that block. So actually this might not be too bad. I think we just need to clean up this trace so that we can go back to using that side channel to analyze this properly. So soldering iron and a bag of capacitors I think is the thing right now. Oh, and maybe some tape. This board is getting crazy again. Alright. So yeah, what we want is under this whole mess, unfortunately. So I want to actually power this off. Cat's looking good. This is so vertical that I think I'm going to get a larger vise for this. Oh, does this one fit? I mean, part of the problem is it's hard to get the microscope under this vise. Or maybe I just make this a little less vertical. I think that'll be good enough for some soldering quickly. Let's at least see if we can get the microscope on it. think I need to rotate this microscope stand to the other side. This microscope stand is actually a lighting clamp. Whoops, did I just turn this off? No. Cool. I guess I do need a little more height under this. Yeah, there's like one adjustment that is pretty much impossible to make on this, and that's the angle of this arm this way. Just kind of annoying. That is the capacitance situation we have. There's my stash. Oh. Just realizing I should probably check the 3.3 volt rail just to make sure that's not where this noise is coming from. I mean, it's kind of looking like LDO oscillation, but I want to rule out external sources before I just make even more of a mess of this. I think I can mostly power this thing up in this crazy state. Just want to make sure this isn't sorting against the vise. I think that's fine. And some ground. Don't off the top of my head know where 3.3 volts is, but I think we can just find it by probing around. DC. Oh, let's have this. We should have the scope on here. Just zooming in on the blue channel. Gonna try probing some stuff. So that's V-core. Looks like we've got almost 200 millivolts of noise. Similar on ground. Let's be using a better ground probe because this stupid wire is not doing us any favors right now. Okay, that is much better. Yeah, I think that's not wildly oscillating right now. That is, I mean, we should zoom in the scope a little bit. Oops. Oh. Oh, is that all coming from the ground? Interesting. Well, not a lot of signal here. I mean, there might even be too much capacitance here. Because like we only want enough capacitance on the LDO to keep it from oscillating. We don't really want to cut the noise on this that much because we're trying to listen to this line. We do want to make sure noise isn't just flooding in externally though. So let's try to find a good 3.3 volt decoupling capacitor around here and see how noisy it is. For that, I'm going to temporarily put the silly ground probe back on. I think one of these other capacitors around here should be 3.3 and we can just measure the noise there. That looks like it. I figured we'd just look for the biggest capacitor and that'd probably be it, which is this one over here. That one's also looking like 3.3. Oh, I also happen to remember off the top of my head some places on the other side of the board where we can always get 3.3. Oh, but you know, this is already the board where I added a bunch of 3.3 volt filtering. Like, I'm slightly getting these two boards confused again, because the other one, the one that is not currently bricked, doesn't have any additional filtering on 3.3, but this is the board where I added a bunch of that, so we should be fine. I'm just turning this over again, since I think this is the side of the board we want to care about right now. I'm going to plug this back into reset. Is this still running? I don't think so. So when I press capital R, it reboots, causing it to boot and then run the experiment and then just have a bunch of noise, which is fine. No more auto trigger. Oh wait, are we getting 2 file system blocks now? Why is that? You see that one with D1 set is the root directory? Oh wait, no, this is the, sorry, I'm just getting disoriented again. We don't have a trigger for the just the directory entry. So yeah, this is the this is the actual file contents. I should probably change the triggers a little bit. Yeah, that's the file allocation table. And this is the stuff we care about over here where the clock isn't running. So, I mean, the power trace is not what I'd like right here. I don't know why it isn't as nice as what I was seeing before. But what I'd really like is to find a different side channel that's easier to automate than the power trace. Let's try high resolution. Excuse me. Did I not type that right on account of sneeze? Maybe I did. You know, I wonder if those capacitors I added are just quieting down the signal too much. Maybe you should take one of them off. Oh. I also forgot to turn the amplifier back on, which might be part of this. Oh yeah, sorry about that scope. 50 ohms. Oh, that's more amplitude. Okay, the problem is not that it's too quiet. The problem was just the amplifier was not on. All right. So this is in high resolution acquire mode, which is giving us more vertical resolution. Not necessarily what we want right now. If we were to rely on the timing or the power side channel, then I think what I would just do is rig this up to run the experiment as quickly as it can and just reboot as soon as it hits this case, and then average it a few times. But anyway, I think that's the next thing. Well, I feel like I might need to take a break from this because it seems to be hitting about the limit of my patience at the moment. But actually, maybe I just need to blow my nose. I'll be right back. Yeah, pardon me. Well, I'm finding myself mostly just planning like what the next step is here. So I'd like to find a better side channel. If I can't, power's fine. Then I will want to change this experiment so that this directory entry is basically hard-coded, but I'm hex editing the particular part of the file that it's reading and then looking to see if it can make further progress. So I think that's the next step on here. Also got some similar work to do on the other PLC with regard to just like fussing with the power and trying to make sure that it's operating smoothly. But yeah, that's pretty much the state that this stuff is in. I think I might sign off and do some of this stuff off stream or just take a break because I'm getting a little bit tired of this particular activity. But there will, as always, be more of this shortly. And if you want to be sure you catch these streams when they go online, if you're interested in the Senrio stuff specifically, there's a separate Twitter account, Senrio Labs, and there's a Twitch stream, Senrio Labs, there that you can follow. If you want to just get like anything that I post on YouTube, you can also set the notifications on my YouTube account. If you just search for Micah Scott, you'll find me. So I think that's pretty much it for this stream. Plenty more to do, just always a question of how much patience there is available in single bursts. So maybe I will try to do a little bit of this debugging off stream and then save some time for a cat camera related stream later, because that would be nice. I've been looking forward to doing more of that. So I think that's pretty much it. Let's get kind of a parting shot of Tuco for a minute or so. Thanks for joining, everyone. I hope some of that was interesting, even if it's quite a lot of yaks deep at this point. Oh, and also, if you came here for the streams but you haven't seen my kind of edited together videos, those might be interesting too. If you check out scanlime.org, you'll see it has a lot of really old blog posts on it too, but the recent content on there is mostly videos that I've edited together that, you know, most of them are around like 20 minutes long. I think the range is like 5 to 30 minutes mostly. But that's kind of the slower, you know, more thoroughly cooked output of this this endeavor. Eventually this stuff gets edited together into stuff that I can distill a lot more progress into a short period of time with. Oh yeah, and Sodium helpfully put a link in the chat. So thanks everybody, thanks for tuning in. I will see you on the rest of the interwebs, and as always, happy hacking.